Start Panta. Hello guys. Hello guys. I don't know whether it was live the first time I said hello. Hello. Best wishes for your cat to start with. We're going to do a session of solving the quant for the CAT 2017 slot 2. This is a slot I took, give or take, a year ago, 11 months ago. So it was a good fun slot. I quite enjoyed myself. It was a fabulous session. I'm going to see if we can mimic that, where we can do this in 60 minutes. And so the idea is going to be to try to solve it in as much as exam conditions as possible. So I'm not going to be teaching much. Sometimes I slip into teaching mode, so ignore that. But I'm going to try to solve this aggressively and not looking to elaborate on this. And the solutions are elaborately provided in multiple places. You can always check them out. Right? So there's several links given in the description of this video, which are all mighty useful. In fact, the guys who the 2IM team have created a fabulous PDF, absolutely outstanding PDF, and so which I think is gold for any student. I would highly recommend any student preparing for CAT 2018 to go through the CAT 2017 paper in that format. And so because the format that's available gives questions and answers straight away, or it's a test taking scenario where you don't have the chance to evaluate the solutions immediately. And this format is brilliant. So it's a PDF where slides come one at a time. I'm going to elaborate on that format as well. I'm going to use that as the base template to have a go at this session, at this. And I'm going to do a 1 hour, 1/3 of CAT mock session. Right? Just to reiterate, all the links that are relevant to this session are available in the description. Please definitely do check that out. Download that PDF and use that to navigate and prepare and practice for your last lap for CAT. That PDF is gold. And so keep that in mind. Also keep in mind that I'm going to focus on solving really quickly. And I'm not going to focus on trying to explain solutions elaborately. There will be a solution chat as well, but that is not the focus. This is a scenario where we're trying to mimic how someone who's going berserk at the paper will operate. Right? So that is the plan. And I'm going to share the screen, take about 2 minutes to describe how that PDF works, because that's how we'll be navigating across the session today. And then jump in. So we're at 9:33. I'm going to keep a timer with my watch, and I'm going to clock out 60 minutes. Hopefully, I'll be able to do justice to the paper and then do a really good job. I don't want to embarrass myself in front of a live audience and score miserably low. So I will be trying to score well and attack the paper really well. And so I'm going to go on to screen share mode. And once I slip into screen share mode, I'm not going to be able to see what you're saying, what you're typing, comments, none of that. But do chat away. We have a fantastic team. They will be able to clarify doubts. And if something is going wrong, so wave giant red flags so that they can rush in and tell me that something's not working, and then we can fix it and go. Fine. So let's have a go at this. 2 minutes for explaining the PDF, and then we're trying to solve this one. Going to screen share mode and share before you can see the rest of the stuff. Wonderful. So this is roughly how your screen will appear, where you can see the bunch of questions, 34 questions, 1 hour. The PDF is built in a way where you click on a particular question. Obviously, I'm not able to click here because I have on the mouse mode. I'm going to go back to the arrow mode. So you can go here and click at question number 6. It will go to 6. You can go to 16. It will go to 16. And that part is clear. Click question number to view the question. And so the real beauty of this PDF comes here. And each question is an outline like this. So this question number 0, we've just included question number 0 to show you how the PDF works. This is going to be a PDF, the link for which is available just beneath this video. And go there, download that PDF, prepare for the last lap of CAT using that PDF. This should be one of the very important exams that you take to crack this exam. Before CAT 2018, you want to take CAT 2017 and go through it well. And so have a clear sense of how this works. The question will appear here. You're going to try solving the question. You want to see the correct answer, click here. This gives you the correct answer, the level of difficulty of the question, the topic it comes from. You want to go back to the question, click here, get back to the question. Click next, you'll go to the next question. Right? It doesn't stop with that. Beauty here, I want to check the answer. I know the answer, but I also want to know how it is solved. If you click on video solution, this thing will open at the right spot where that particular question is solved, a video solution which runs on a Chrome or IE browser. For some reason, I'm having the default setting as the IE browser. I'm sure most of you guys work with the Chrome or something else. This will open up the exact location of that particular question on the video in your browser. So any one question you see, you can just jump in, see the answer that is right, see the topic that works, or you want to see the solution, click, and then you're back to the question. And so use this to extensively solve the actual paper before your CAT, because it's a frightfully useful format where you see the question, try to answer it, see the answer, see if it works. If you want to see the solution, click, see the solution, move to the next one. And you can do the entire wrap really quickly. Right? Now I'm going to jump out of this and go to the questions part. I'm going to set myself up. The moment I go into the question mode, there's no chatter. I'm going to jump in and try to solve questions left, right, and center. And there's no the last second for having a, if you're going to chase me along with this and you're trying to solve questions alongside me as well, take a deep breath, drink water, do whatever it is that you need to do. I'm going to drink water. And then we go berserk. 60 minutes of intense solving. I've seen the time, it's 9:37 by my watch. Here we go. Numbers 1, 2, 3 till 9 are arranged in a 3x3 square grid in such a way that each number occurs once, and the entries along each column, each row, and each of the two diagonals add up to the same value. And so the top left and top right entries, are 6 and 2. Right, so first step 1 to 9, 9 into 10 by 2, the total is 45. So each row, each column should add up to 45. In the bottom middle entry, we need to find this. So each row, each column should add up to 15. So 6 plus 2 is 8. This should be 7. And so we are more or less, we've got to fill the entire grid. We know this is 6, 7, 2. The number most likely in the middle is going to be 5. Mainly because 5 is the middle number. So I'm going to work with 5. So 6, 5 makes this 4. 7, 5, 12 makes this 3. 3 plus 4, 7. This makes it 8. 6, 8, 1, 2, 4, 6, 9. This works. It ticks all the boxes. I've got one grid. That's all I need. Bottom middle entry is 3. I'm going to look for, this is not a t-tag question. So I'm going to mark away 3. Right? Next one, in a 10-kilometer race, A, B, and C, each running at uniform speed, get the gold, silver, and bronze medals. If A beats B by 1 kilometer and B beats C by 1 kilometer, when A runs 10, B runs 9. When B runs 10, C runs 9. How many meters does A beat C? So when A runs 10, 9. So when B is run 9, C would have run 8.1, or in a 10-kilometer race, A defeats by 1.9 kilometers, 1900 meters. The answer has got to be 1900. Be very careful or you're doing the whole damn thing and losing marks. Bottle 1 contains milk and water in the ratio 7:2. Bottle 2, so 7:2 milk and water. Bottle 2 milk and water 9:4. To combined ratio of 3:1. So I'm mixing 7/9 milk and 9/13 milk to get 3/4 milk. I know how this is done. I'm going to do the simplification. So 9, 13, and 4. I'm going to take the LCM of the whole damn thing, and so that I get that overall clarity. 9 into 4 is 52. 52 into 13, 62, 65, 67, 676. My denominator. So this is something by 676, something by 676, something by 676. So 3/4 is something by 676. I wish I had a calculator, but probably this is too difficult. So I'm going to do 9/13, 3/4, which is greater. Let me do this. 3/4 minus 9/13. LCM is 52. 39 minus 36. So 3/52. This side is 3/52. 3/4. 7/9 minus 3/4. So this is something by 36, 28 by 36 minus 27 by 36. This is 1 by 36. The ratio is 3 by 52 is to 1 by 36, or this is 108 is to 52. You divide by 4, 27 is to 13. 27 is to 13 is what I'm looking for. I could have jumped at this 13 because 13 is a giveaway number. Too slow, we need to pick up some speed. Arun drove from home to his hostel at 60 miles per hour. While returning home, he drove half along the same route at a speed of 25 miles per hour, then took a bypass road which increases driving distance by 5 miles, but allowed him to drive at 50 miles per hour along this bypass road. If his return journey took 30 minutes more than his onward journey, then the total distance traveled by him. And so, let's do this. D by 60 is the time taken for the onward journey. While he drove half along the same road at 25 miles, so D by 2 by 25 is the time taken. Second leg is D by 2 plus 5 by 50. D by 60 is the time taken in the first iteration. Return journey is D by 2 by 25 plus D by 2 plus 5 by 50. This plus 1 by 2, half an hour more is this. And so I'm going to write this down in the next page, next slide. D by 60 plus 1 by 2 equals D by 2 by 25 plus D by 2 plus 5 by 50. And so D by 60 plus 1 by 2 equals D by 50 plus D by 100 plus 1 by 10. So this is 2D by 100, D by 60, 3D by 100 minus D by 60 equals 1 by 2 minus 1 by 10. This is 4 by 10, 2 by 5 equals LCM is 300, 9D by 300 minus 5D by 300. 4D by 300 or D by 75. This gets knocked off as 15. I get D to be 30 miles, which is not even there in the answer. And the total distance traveled by him. So D is 30 miles. So D is what he covers one way. D covers one way, 30 plus 30, 60 plus 5, 65 miles. This works. Brilliant. One of the shirts produced by in a factory, 15% are defective or 20% of the rest. So 15% are defective, 20% of 85%, that is 17% are sold to the domestic markets. So 68% is the remaining 32, 68%. 68% corresponds to 8840. The number of shirts, 100% is 8840 into 100 by 68. Something tells me this number will be divisible wonderfully. 4420 by 34, 2210 by 17. 17 into 13 is this 13000. I'm looking at this number. This is good. Average height of 22 toddlers increases by 2 inches when 2 of them leave the group. So 22, we have x, 20 equal to x plus 2, average. The average height of these 2 toddlers is 1/3 the average height of the original 22. Then the average height in inches of the remaining 20 toddlers is, so 20 into x plus 2 plus 2. If the average height of these 2 toddlers is 1/3 of the average height into x by 3 equals 22x. So I'm going to multiply by 3 on both sides. So 60x plus 120 plus 2x equals 66x. This is 62x, so 120 equals 4x, or x is 30. Then the average height in inches of the remaining 20 toddlers is 32 inches. X plus 2. Done. Let's go to the next one. Manufacturer of a table sells it to a wholesale dealer at a price of 10%. The wholesale dealer sells the table to a retailer at a profit of 30%. So X, 1.1x, 1.43x. Finally, the retailer sells it to a customer at a profit of 50%. So 1.43 into 1.5 equals 4290. Then find X, 1.43x into 1.5. So 429. Thankfully, that's a multiple of 11. Should also be a multiple of 13. So 143 into 3 is this number. So let's divide by this. We'll get 3000. 1.5x is 3000 or x is 2000. Done. I know that 11 into 13 is 143. A tank has an inlet pipe and an outlet pipe. Outlet pipe is closed and the inlet pipe fills the empty tank in 8 hours. So inlet in 1 hour does 1 by 8. The outlet pipe is opened, then the inlet pipe fills in 1 by 10. Both together is 1 by 10. So 1 by 8 minus 1 by 10 is what the outlet lets out. LCM is 45 by 40, 4 by 40, 1 by 40. If only the outlet pipe is open, then how many hours does the full tank become half full? 20 hours. Outlet pipe takes 40 hours to drain the full tank, 20 hours to drain half of it. Mine buys some candies for 15 a dozen and an equal number of candies at 12 a dozen. 15 a dozen. 15 by 12 into n plus 12 by 12 into n. He sells all for 16.5 a dozen. So 16.5 into 2n and makes a profit of rupees 150. How many dozens of candies did he buy? Let's assume he bought n dozens, so this by 12 will disappear. So 15n, n dozens, 12n, n dozens, sells at 16.5 into 2n dozens. So 27n plus 150 equals 33n. 6n equals 150, n is 25. That means how many dozens of, he bought twice of that, not 25 but 50. He buys 2n dozens, n is 25, so 50 dozens totally. The village, the production of food grains increased by 40% and the per capita production of food grains increased by 27% during the same period. And so x became 1.4x, y became something, x by y became 1.27 times x by y. The percentage by which the population of the village increased during this. Some k, 1.4x by k equals 1.27 x by y. Or k equals 1.4 by 1.27 y. Whatever that number turns out to, once again, I would have loved to have a calculator, but I'm not given that. So I'm going to blame this on, it's not 13%, it's less than 13%, it's probably 10, yeah. 1.27, so 127 plus 12.7 is 139.7, roughly 140, 10%. Done. I'm glad I don't have a calculator, otherwise I would have typed that in. A, B, C are three positive integers such that the A and B are in the ratio 3:4. Wonderful. B and C is in the ratio 2:1, so 4:2. Which of the following is a possible value of A plus B plus C? A plus B plus C should be a multiple of 9, 207. Done. The motorbike leaves point A at 1 p.m. and moves towards point B at a uniform speed. So at 1 p.m., A to B. A car leaves point B at 2 p.m. and moves towards point A at a uniform speed, which is double that of the motorbike. So bike travels at X, car travels at 2X. Bike leaves at 1 p.m. and the car leaves at 2 p.m. Okay, this is at 1 p.m. and 2 p.m. They meet at 3:40 at a point which is 168 kilometers from A at 3:40. At 3:40 they meet. This distance is 168 kilometers. what is the distance in kilometers between A and B? So this guy travels for 2 hours and 40 minutes. This guy travels for 1 hour and 40 minutes. And so A travels for 2 hours and 40 minutes, 2 p.m. and moves towards point A at a uniform speed, which is double that of the mouse. Right? They meet at 3:40 p.m. at a point which is 168 kilometers from A. Point B and moves towards point A. Okay, this guy travels at 2 hours 40 minutes, 2 by 3, 8 by 3 hours. He travels for only 5 by 3 hours. Okay, x into 8 by 3 equals 168. We want to find what is x into 8 by 3 plus 2x into 5 by 3. This is 8x by 3, this is 10x by 3, 4:5, or if 4 were 168, what is 9? That's our question. 168 into 9 by 4, 84, 42, 42 into 9, 420 minus 42, 380, 378. This is what we're looking for. Bam, done. Amal can complete a job in 10 days and Bimal can complete it in 8 days. Amal, Bimal and Kamal complete the job in 4 days. 1 by 10 plus 1 by 8 plus 1 by k equals 1 by 4. LCM is 44 by 40 plus 5 by 40 plus 1 by k equals 10 by 40, or k is 40. So k will take 40 days to do it. So Amal works at a rate of 4 by 40, Vimal at a rate of 5 by 40, Kamal at the rate of 1 by 40. They're paid 1,000 rupees as a remuneration. They should be getting in the ratio 4:5:1, shared by them in proportion to their work. Kamal's share should be 1/10. 1/10 of 1,000 is 100. Done. The first having water and liquid A in the ratio 1:2, water A 1:2. Second having water and liquid B in the ratio 1:3, water and B in the ratio 1:3. Third having water and liquid C in the ratio 1:4, 1:4, wonderful. These three mixtures of A, B and C respectively are further mixed in the proportion 4:3:2. So we have 4 units of this, 3 of this and 2 of that. Right? So in the resulting mixture, right? So I'm going to think about only water. I'm going to track water and A and water and B. So water would be 4 units of 1/3 plus 3 units of 1/4 plus 2 units of 1/5. That's how much water is going to be there in terms of the ratios. We already know 4 into 1 by 3 plus 3 into 1 by 4 plus 2 into 1 by 5. So LCM, we're going to take it as 60, 80 by 60 plus 45 by 60, 3 into 1 by 4 plus 2 into 12, 24 by 60. So just add these three up. 4 plus 5, 9, 2 plus 4, 6 plus 8, 14, 149 by 60. That is the amount of water that is going to be present. Amount of liquid B, and then liquid B and C. More water than liquid B. Let's find out how much liquid B is going to be there. Liquid B would be 3/4 of 3 units. This is 9 by 4. The amount of liquid C would be 2 units of 4 by 5. This is 8 by 5. And so more water than liquid B. Water is 149 by 60. So I'm going to, water equals 149 by 60. A equals 4 times 2 by 3. 4 into 2 by 3, 8 by 3 B is going to be 9 by 4. C is going to be 8 by 5. This is what we finally have in that mixture. So the same amount of water and liquid B, that's not true, that's not correct. So this is out. Same amount of liquids B and C, that's not correct. More water than liquid B. 9 by 4 is 2, 1 by 4, more water, 60, 120. Oh, it's almost 2.5. This works. More water than liquid A. That's not the case. There is more A than this. So choice C. Tough one, at least time consuming. Probably worth skipping. A, B, C, D, E, F is a regular hexagon with each side of length 1 centimeter. I love regular hexagon questions. So I'm going to definitely nail this. And so A, B, C, D, E, F. The area of a square with AC as one side. AC as one side. So length each side 1 centimeters, 120 degrees. This is the root 3. Read root 3 into root 3, 3 units. Square of side AC as one side. The base of a vertical pillar with uniform cross section is a trapezium whose parallel sides are of length 10 and 20. So 20, 10. Other two sides are of equal length. Okay, sounds good. So think about this. This will be 5. This is 5. So 10, 10. Other two sides are of equal, and the perpendicular distance between the parallel sides of the trapezium is 12. So 12, 13, 12, 13. The height of the pillar is 20 centimeters, and the total area in square centimeters of all 6 surfaces. Wonderful. Will be trapezium's area, which is 10 into 12, 120, plus half into 5 into 12. Half into 5 into 12 into 2 is this triangle and this triangle. And so that is 60 square units plus 10 into 12, 120. Area of the trapezium is 180. We'll have 2 trapeziums, 180 plus 180. Right? So 360 is in the back. Every other side will be like a rectangle. Imagine there's something sitting on top of this. The height of the pillar is 20. So one width is 830. The perimeter of this is what we need to count. 10, 13 plus 13 plus 10 plus 20. 30 plus 26 is 56. 56 into 20 is 1120 plus 36. We're looking at 1480. Bang, done. Points 2 by 2,5 and 6,3 are 2 endpoints of a diagonal of a rectangle. Amazing question. I think that this is a tough question. 2,5 and 6,3. 6,3, 2,5. Other diagonal has the equation y equal to 3x plus c. So an equation like this. Y equal to 3x plus c. Wonderful. Now we've got this. The diagonals of a rectangle bisect each other. So y equal to 3x plus c should pass through the midpoint. 2 plus 6 by 2, 4, 5 plus 3 by 2, 4. So y equal to 3x plus c, 4, 4, 4 equals 12 plus c, c is minus 8, done. ABC is a quadrilateral inscribed inside a circle with center O, wonderful. Ooh, that's an ugly circle. ABCD, angle COD is 120, BAC, so A, B, CD, BAC is 30, COD is 120. I've drawn a really bad diagram. So C and D, COD is 120, and then A and C. So A and B, angle BAC, angle BAC. Let's do this. BAC. Angle BAC. This is 30. Angle COD is 120. What is the value of angle BCD? We want to find this angle. This is 120, this angle is 60. If this angle is 60, the whole angle is 90. If that is 90, the opposite angle should also be 90. Opposite angles of a cyclic quadrilateral are supplementary, done. 90. Good diagram, we are through. I was worried this might happen. I think our wonderful PowerPoint has crashed. So I'm going to close this and then start afresh. And so this can happen. This has happened before, so I know what to do. I'm going to restart the program. We are a little bit behind time, so I'm going to let's see if this can work. We are at question number. I hope you can still continue to see my screen. We're continuing on screen share. We've done question number 18. We're going to 19. If three sides of a rectangular park have a total length of 400, then the area of the park is maximum when the length in feet of its longer side is. Oops, something is wrong. I'm not able to move my monitor. 1 second. Yeah, this is sure works. Sorry about that. Yeah, three sides of a rectangular park, sides add up to 400. So x, y, x, 2x plus y equals 400. Maximum, we need to maximize xy. What is the maximum value of xy? When is xy maximum? That's what we need to do. So y is 400 minus 2x. X into 400 minus 2x should be maximum. 400x minus 2x square should be maximum. Or 200x minus x square should be maximum. X square minus 200x should be minimum. X minus 100 the whole square, or x should be 100. This is 100, 200, 100. That's the best combination for it. Length of the longer side should be 200. These three add up to 400. Longest side should be 200. Let P be an interior point of a right angled isosceles triangle ABC with hypotenuse AB. ABC. P is an interior point if the perpendicular distance P from each of AB, BC and CA. So, wonderful. Perpendicular distance from each of this. Imagine that perpendicular distance from each of this. What is this line called? That is the end radius. Our end radius is 4 into root 2 minus 1. This is a right angle triangle A root 2A. The end radius R is A plus A minus root 2A, A plus B minus H by 2, 2A minus root 2A by 2, A minus A by root 2 equals 4 into root 2 minus 1, or A by root 2 into root 2 minus 1 is 4 into root 2 minus 1, or A is 4 root 2. Okay. Then area in square centimeter of triangle ABC. Area is half into A square, 1 by 2 into 4 root 2 into 4 root 2, or 16 square units. The product of three consecutive positive integers is 15600. Then sum of the squares of these integers, there are 2 zeros sitting there. So sum 24, 25, 12 into 13, 24 into 25 into 26 should be it. 25 into 4 is 100, 6 into 26 is 156. Sum of the squares of these integers, 24 squares, 576, 625, 676, 12, 17, 7, 1, 8, 10, 17, 7, 1, 18, 1, 8, 7, 7. Good. Let's go to the next one. X is a real number such that log 5 to the base 3 is log of 2 plus x to the base 5. Then which of the following is true? log 5 to the base 3 log of 2 plus x to the base 5. Let's think about this. This number should lie between 1 and 2, or log of 2 plus x to the base 5 less than 2, or 2 plus x lies between 5 and 25. It's a starting point. X lies between 3 and 23. X lies between 3 and 23. That lucky enough that choice exists. We're done. F of x equal to x square, g of x equal to 2 power x. Then the value of f of g of x plus g of f of x. G of x is g of 1 is 2. So f of 2 plus g of f of 1 is 1. And f of 2 is 2 square. So this is f of 4 plus g of 1. G of 1 is g of 1 plus 2 power x. F of 4 is 16, 16 plus 2, 18. Done. The minimum possible value of the sum of the squares, the roots of the equation. So we have alpha square plus beta square. It's alpha plus beta the whole square minus 2 alpha beta. Sum of the roots square minus b by a the whole square. So a plus 3 the whole square minus 2 times a plus 5. The minimum possible value of this, a square plus 6a plus 9 minus 2a minus 10. So a square plus 4a minus 1. A square plus 4a plus 4 minus 5. Minimum possible value is, this is a plus 2 the whole square minus 5. We're getting that the value can be minus 5, which is evidently wrong. So I'm going to do this all over again. Alpha plus beta is minus of a plus 3. Alpha beta is minus of a plus 5. Minus 2 alpha beta. Okay, this should be like this. Lucky. They should have given that choice. A square plus 6a plus 9 plus 2a plus 10. A square plus 8a plus 19. A plus 4 the whole square plus 3. Bam. Got very lucky there. 9 power x minus 0.5 minus 2 power 2x minus 2 equals 4 power x minus 3 power 2x minus 3. This is interesting. I'm going to make these two in terms of that. So this is 3 power 2x minus 1 minus 2 power 2x minus 2 equals 2 power 2x minus 3 power 2x minus 3. Bring this side. 3 power 2x minus 1 plus 3 power 2x minus 3 equals 2 power 2x plus 2 power 2x minus 2. 3 power 2x minus 3 into 9 plus 1 equals 2 power 2x minus 2 into 4 plus 1. 3 power 2x minus 3 into 10 equals 2 power 2x minus 2 into 5. 3 power 2x minus 3 equals 2 power 2x minus 3. Wonderful. Or 2x minus 3 is 0, x equals 3 by 2. Log of 2 power a into 3 power b into 5 power c is the arithmetic mean of log of 2 square into 2 cube into 5 into 5. And a equals, arithmetic mean of these three numbers is this number. So this is log of this plus log of this plus log of this by 3, or 2 power a into 2 power b into 5 power c, the whole cube, equals 2 square into 3 cube into 5 into 2 power 6, multiplying all of this. So I'm going to multiply like that. 2 power 2 square, 2 power 6, 2 power 1 is 2 power 9 into 3 power 3 plus 1 4 plus 2 6 into 5 power 1 plus 7 8 plus 4 12. This is 3a 3b 3c. A is 3, b is 2, a should be 3. We need to find only a. Done. A1, A2, A3, A4, A5 be a sequence of 5 consecutive odd numbers. Consider a new sequence of 5 consecutive even numbers ending with 2A3. A1, A2, A3, A4, A5, 2A3, 2A2. Sorry, 5 consecutive odd numbers ending with 2A3. Minus 2, minus 4, minus 6, minus 8. The sum of the numbers in the new sequence is 450. Sum of the numbers is 450. Middle number should be 90. Average of that should be 92. Should be 94. So 2A3 is 94. A3 is 47. A4 is 49. A5 should be 51. 5 consecutive odd numbers. New sequence. Consecutive even numbers ending with 2A3. The middle term is 90. So we get the A3 term to be 94, 47, 49, 51. I think that's the one I got wrong. Hopefully I've gotten it right this time. How many different pairs of A, B of positive integers are there such that 1 by A plus 1 by B equal to 1 by 9? This is tough. I'm going to come back to this. Very interesting question. Could be time consuming. 8 identical pens be distributed among Amal, Bimal and Kamal. So A plus B plus C is equal to 8. Amal gets at least 1. So let's put 1 plus P. Bimal gets at least 2. 2 plus Q. And Kamal gets at least 3. 3 plus R equal to 8. Or P plus Q plus R equal to 2. P, Q, R can be 0. That's what we are saying here. Amal gets at least 1. You can get exactly 1. How many ways are there of P plus Q plus R being 2 where these 3 can be 0? We can do a simple count, or we can eliminate the 0 possibility, then increase this to 5. It's 5C2 is what we are looking at finally, I think. But I'm just going to do this more rigorously. I think we have time. We can find this. So it could be 200, 020, 002, right? Or 110, 101, 011. Is that it? So P plus Q plus R equal to 2. Then we get exactly 6 ways of doing this, but that's not 5C2. So we can do this as KLM, where KLM are 1 more than this. K plus A plus M would be 5. Yeah, 4C2, 6. 6 different ways are there. I shouldn't have gone for a 10. So we can use the formula N plus R minus 1, C R minus 1. So 6 ways. Go to the next one. How many 4-digit numbers that are divisible by 6 can be formed using the digit 0, 2, 3, 4, and 6, such that no digit is used more than once, and 0 does not occur in the leftmost position. It's the 4-digit number. So 1, 2, 3, 4, 5 digits. So one thing gets left over, which is divisible by 6. Be multiple of 2 and of 3. 0 plus 2 plus 3 plus 4 plus 6. 2 plus 3 plus 4 plus 6. We add this 5, 9, 15. The sum is 15. If you leave something out, we should still get 15. Or you can leave out a 0, 3, or 6. So the digits we have are 0, 2, 3, 4, or 0, 2, 4, 6, or 2, 3, 4, 6. Within this, we want even numbers and 4-digit numbers. And so let's do this very slowly. Even numbers, so it could end with 2. And so we have 0, 3, 4. It can be rearranged in 3 factorial ways, of which 0 will start with this. So 4 numbers ending with 2. Ending with 4, again 4 numbers. So 8 numbers of this combo. You could end with 2. You'll have 0, 4, 6 being rearranged. Be 4, 0, 6, 6, 0, 4, 4, 6, 0, 4, 6. So 4 ways. It could end with 4 ways. It could end with 6, 4 ways. So starting with this, there are 12 outcomes possible. 2, 3, 4, 6. You could end in 2, 4, or 6. Ending with 2, you could have 3, 4, and 6. 6, 6, 6, 18, 8 plus 12, 20, 20 plus 18, 38 different ways of this happening. We have 38 different 4-digit numbers which are divisible by 6 with only those numbers 0, 2, 3, 4, and 6. F of AB equals F of A into F of B for all positive integers A and B. The largest possible value of F of 1, this is 1. This is a multiplicative identity. F of AB is F of A into F of B. F of A into 1 is F of A into F of 1. F of A equals F of A into F of 1. Either F of 1 is 0 and F of A is also 0. If F of A is not equal to 0, for all A, this should work for any A, either it's a complete constant or F of 1 equal to 1. Maximum possible value is 1. F of x equals 2x minus 5, g of x equals 7 minus 2x. Then f of x plus g of x. So 2x minus 5 plus 7 minus 2x equals modulus of 2x minus 5 plus modulus of 7 minus 2x. So 2x goes off, mod 2. So modulus of 2x minus 5 plus modulus of 7 minus 2x should be equal to 2. It's a very simple question. Either both. So this will be 2x minus 5 and this will be 7 minus 2x. If 2x minus 5 and x is greater than 5 by 2, here 7 minus 2x should be greater than 0, or 7 greater than 2x, or x less than 7 by 2. So x lies between 5 by 2 and 7 by 2. That works. Or this becomes 5 minus 2x, this becomes 2x minus 7, become 5 by 2, that's not possible. Between 5 by 2 and 7 by 2, yeah, we have it. Infinite geometric progression has the property that an equals 3 times an plus 1 plus an plus 2 and so on. A1 plus A2 plus A3 is 32, then A5 is. And so an is 3 times an plus 1. So common ratio could be 1 by r, could be r. So A1 by 1 minus r is 32. A1 equals 3 times A2 by 1 minus r, or A1 equals 3A2. The common ratio is 1 by 3. And so A1 by 1 minus 1 by 3 is 32. A1 into 3 by 2 is 32. A1 by 2 by 3. A1 into 3 by 2 is 32. A1 is 64 by 3. Evidently doing something wrong here. A1 by 1 minus r is 32. Sum to infinite terms. Starting from A2, sum to infinite terms is A2 by 1 minus r. This is 3 times that. A1 equals 3A2, or A1 into 1 by 3 is A2. A1 by 1 minus 1 by 3 is 32. A1 by 2/3 is 32. A1 equals 32 into 2 by 3. Then A5 is. I'm going to do this all over again. I'm making some mistake here. I'm going to fix that. An is 3 times sum of all terms. So A1 equals 3 times A2 plus A3 all the way to this. So A1 was 3 times A2 by 1 minus r. A1 into r So sorry. 1 minus r by r is 3. 1 minus r is 3r. 4r is 1. R is 1 by 4. That works. So a1 by 3 by 4 is 32. a1 equals 32 into 4 by 3. Sorry, 32 into 3 by 4. Or a1 is 24. a1 equals 24. a2 equals 24 into 1 by 4 is 6. a3 is 6 into 1 by 4, 3 by 2. a4 is 3 into 1 by 4, 3 by 8, 3 by 32. Done. 1 by 2, 1 by 5. So this is 1 by 2 minus 1 by 5 is 3 by 5. So this is 1/3 of 1 by 2 minus 1 by 5 plus 1/3 of 1 by 8 minus 1 by 11 plus 1/3 of 1 by 11 minus 1 by 14. So this is partial fractions. We just need to find the final term. There's a 1 by 3 sitting there somewhere. I think we should be able to nail this. So it is 1 by 3 into 1 by 2 minus whatever that last term is going to be. a1 is 2, a2 is 5, a3 is 8, or an is 3n minus 1. a100 is 3 into 100 minus 1, which is 299. Not a1, I'm finding this is the first part of it. Or the 100th term is 1 by 299 into 302. So 1 by 2 minus 1 by 302, or 1/3 of 151 minus 1 by 302. 150 by 302 into 1/3 is 50 by 302, 25 by 151. Done. One question, 28th one, if I'm not mistaken. I'm going to attack that. 1 by a plus 1 by b. I know how to do this. Let's say it cannot be 1 by 1. A and b, a less than or equal to b. So a and b are both greater than 9. And so 1 by 18 plus 1 by 18 is obviously 1 by 9. Half and half. A less than or equal to b. So 18 comma 18 works. Brilliant. So all we need to do, one of the numbers should be greater than half of 1 by 9. Other should be less than half of 1 by 9. A is less than or equal to b. So 1 by a is the larger part. And so a can take values 10, 11, 12, 13, 14, all the way till 18. 18 comma 18 works. 17 won't work. 16, 1 by 16 plus 1 by, so 1 by 9 minus 1 by 16. LCM is 144, doesn't work. So 18 works, 17 doesn't work, 16 doesn't work. 15, 1 by 9 minus 1 by 15. LCM is 45, 5 by 45 minus 3 by 45, 2 by 45. 15 doesn't work. 14 won't work. 1 by 9 minus 1 by 14. 126. 14 minus 9, 14 won't work. 13 won't work. 12. 1 by 9 minus 1 by 12. LCM is 36. 4 minus 3, 36 works. 1 by 12 works, so 12 works. 11. 1 by 9 minus 1 by 11. 2 by 99 doesn't work. 10. 1 by 9 minus 1 by 10. This is 1 by 90. That works. 10 works. So 18 comma 18 works. 12 comma 36 works. 10 comma 90 works. 1 by 10 plus 1 by 90 is 1 by 9. 1 by 12 plus 1 by 36 is 1 by 9. 1 by 18 plus 1 by 18. How many different pairs? 3 pairs. We're ahead of time. Maybe I think I just rushed off too much. I was not really comfortable with a couple of questions. I wanted to come back and revisit them. but I have not jotted down the question numbers. I'm going to go over this again. So some of the diagrams that we originally had there, they're lost because we had to save and do this again. I think question number 6 was a little bit of a nightmare. 6 is fine. We got this answer is 32. That is fine. I'm not going to check that. This is also fine. I'm going to go over the whole thing again for 2-3 minutes because I don't want to end up wasting time. This answer was 5 that I'm comfortable with. 1900 meters, that is fine. 27 is to 13. This is 1900. 65 miles, so 30 miles at 60 miles per hour, half an hour. And then for 25 miles per hour for 15 miles, 15 by 25 plus 20 by 15. This 3 by 5 plus 2 by 5, which is 1, so that works. Wonderful. This we know 13,000, this we're happy with. 32, this we're happy with. Wholesale dealer is also fine. 2,000 becomes 2,200. 2200 into 1.3, whatever that becomes. 22 into 13, 6222860 into 3 by 2, 143. This also works. Inlet pipe to fill it, what, 40 hours, and then half full, 20 hours. 15 and 16 and this is fine. So 15 into n plus 12 into n, 16.5 into 2n. This plus 150, 27, 33, 6 n is 150, n is 25, he buys 50 dozens, it's also fine. 50%, 1.27 into 1.1 is 1.4, 10%, that is fine. Of course, you should sign up as a trial user and try out these questions. So 700 questions are absolutely fabulous. A is to B is to C is a multiple of 9, we're fine with this. 1 p.m., 2 p.m., 4:5 ratio, 168 plus 210, 378. This is also fine. 1 by 10, 1 by 8, 1 by 40. It's also fine, 100 rupees. This is tricky, but this one was right. 1:1 is to root 3. Diagonal A, B, C. This is root 3, 120 degrees. Root 3 into root 3 is 3. That is fine. This we got right. So 360 plus 1120 is also fine. Wonderful question. Diagonals bisect each other, -8. This we got right. Opposite angles of the quadrilateral. 18 is a wonderful question. 19, 400, 100, 200, 100. That's the best scenario. Just going to cross check this. Maybe we put 120, 120, 160. So 120 into 160 compared with 100 into 200. When does the area maximum? 2 zeros go away, 2 zeros go away. 12 into 16 is 192. This is 200. This is better. Yeah, that works. In radiuses, this we might probably want to check. 4 into root 2 minus 1. I'll do it in the next slide. 4 into root 2 minus 1 is a plus a minus root 2a by 2. So this is 8. 8 into root 2 minus 1 is 2a minus root 2a, or root 2a into root 2 minus 1. Or a is 4 root 2, area is half into 4 root 2 into 4 root 2, 16. That's what we got. That is fine. This is fine. 676, 576, 625. The last digit is 7, but that doesn't help us much. 1877, not 1777. We had these 3 numbers. That is fine. This we did between 3 and 23. That is fine. This we did methodically. I don't think we got this one wrong. We still have time, so I'm going to verify this as well. F of 2. F of g of 2. G of 2 is 4. F of g of 2 X is 1, so we need to find f of g of 1. So f of g of 1, g of 1 is 2, so we find f of 2 plus f of 1 is 1 plus g of 1. G of 1 is 2, this is in the bag. F of 2 is 4, 4 square plus 2, 16 plus 2, 18, that is fine. I struggled. Sum of the roots is minus b by a, product of the roots is plus c by a. So alpha into beta is minus of a plus 5. So minus 2 alpha beta is plus 2 times a plus 5. Therefore, it is 3. That is fine. But x is 3 by 2. 3 by 2 minus 1 by 2 is 1. 9 power 1 minus 2 power 2. 3 minus 2 is 1 equals 4 power 3 by 2. 4 power 3 by 2. Okay. Minus 3 power 3 by 2. 3 minus 3 is 0. 9 power 1 minus 2 power 1 is 9 minus 2 is 7, which is nothing but 8 minus 1 7. Yeah, that works. Log of this plus log of this plus log of this by 3. Log of 3 numbers by 3 is 3 times this. So this cube is this. So that is fine. Geometric progression, that also works. This is the one that I got wrong. So this irritates me. New sequence of 5 consecutive even numbers ending with 2a3. Some of the new sequence is 450. So the middle number should be 90. It ends with 2a3, or 2a3 should be 94, or a3 should be 47, 47, 49, 51. A5 should be 51. I think that is right. Yes, we did 3 pairs, 18, 18, 10, 90, 12, 36. We got to this 4C2. I initially computed as 5C2, 4C2, which is 6. That's fine. This took some time. Maybe we'll revisit this. This is fine. We know this one. This is also fine. This is also fine because we struggled and got it. I'm less worried about it. This is also fine. I'm going to just revisit this. No good reason anyway. The machine has crashed. I think we're good and done for the day. I'm going to stop sharing the screen. Come back and have a chat with you guys. And hopefully, I've not embarrassed myself. So I'm going to stop sharing the screen. Okay, and then we're going to do a Control-Shift-Escape, kill this process because our PowerPoint is not cooperating. It was a good session, I thought. I don't know, maybe we went too fast in the middle, so maybe the understanding part would have struggled a little bit. But all in all, I thought it was a decent session. So a bunch of questions we have discussed. I think we finished a little sooner than we thought we might have. Don't kill the process. We will lose all your ink markings. So have I killed the process? I think I've killed the process. Sorry. So I just saw a comment right now saying don't kill the process. But even if I had not killed the process would have been lost. And I'm going to do a quite quick round of discussions. I'm going to discuss some questions. I'm going to see have a chat and analyze this paper and see what we could have done well, what we could have done poorly. So I'm going to see some questions and see if there are some questions. If you've asked some questions, spend the extra 20 seconds to convince yourself. So I think maybe something we got wrong. Let us see if I can answer. If you have any questions, come back and give a ping. The last time I did more talking, so I was trying to do a session where we could go slowly. This time we just wanted to go berserk, and so quite possible that the session would have been slightly quick because I've done this session before a year ago, but I took the CAD, so probably I'm familiar with some questions. So. And I'm trying to mimic exam conditions and go really quickly. And so this is probably not the best session to learn from basics. Maybe we'll do a session where we do this slowly and nicely and wonderfully and discuss these solutions. I'm going to have a go at some of these questions and see how we can analyze this paper, how we can think about this paper a little bit better. And so Unfortunately, I have killed PowerPoint. So I'm going to come back and restart PowerPoint. So I'm going to end task. Quite a few processes sitting there. End the PowerPoint presentation. So I'm killing that. And we will restart PowerPoint, and then maybe we can do a PowerPoint share where we share the screen, and then discuss this in depth. Fine. Once again, just a quick recap of this session in PDF form is going to be available in the discussion. A format giving you an outline for what all sessions are possible and clear is going to be present in the description. If it's already not present, it will be present. The PDF itself is fabulous. It helps you navigate across questions, across sections really well. You can see the question, you can see the answer, you can see the solution video. The solution video is going to be embedded from this. For a slightly trickier set of questions, I'm going to come back and do one more round of solution. So if you have any set of questions where you want us to do a more detailed solution, I see that the hexagon question with angle 120 degrees is very high. So that is something probably we'll revisit and discuss this. And I'm going to discuss a few questions kind of in depth, not in the solving mode, but in the discussion mode. Before that, I want to do a very quick recap and then say which questions are worth going for, and then discuss how you might have approached this with the idea of saying, look, I'm going to hit 25 questions, probably not 34, but 25, and then get them right. And so I'm going to go back to the presentation, open this, and then I'm going to go question by question and share the screen for good measure. And so I'm going to share screen, discuss this paper, have a strategy towards what we are doing, how you will approach this, how you are going to think about this paper, and then discuss some specific questions one more time, the trickier ones. For when you're discussing specific questions, before we do the screen share again, I'm going to get a request for which questions you want discussed, and then maybe 6 or 7 of them, we'll go over them again just to see that solution slowly, to notice how it works. Right? So first up, I'm going to share the screen, and then I'm going to do a very quick recap of the entire thing. And so first question, tricky, because you need to draw the grid. And so now I know one wonderful thing from this that I know already is you put a grid like this. The number in the middle is going to be a part of this, and this. It's going to be part of 4 different sums. So it's very large. Suppose this number were 9, then this should be small, 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 this should be small. 9 is so large, and you need to accommodate 9, then the other 2 numbers should add up to only 6. It should become very small. That ain't going to happen. It can't be 1 either. There is every chance, because this diagonal also adds up. The number here, which is part of many sums, should be the most in-between number possible. The moment you get that, you're through. You're told that this is 6, this is 2. You're told that this is 5. You know, this is 9, and then you fill everything up. There's nothing more to this question at all, practically. And so that idea is important. So I wouldn't have touched question number 1. 1, I don't like, I don't want to do. 2, I like. 2 is just a ratio question, A, B, C. So this is 10, 9, 10, 9, find this number, and then you're through. Key point here, a point where a number of people got a negative marking thing, is how many meters does. So I've said this many times over. The extra 10 seconds that you spend reading and rereading and getting the detail right is worth its weight in gold. And so don't rush through in that last bit. So question number 2, we're definitely going for in round 1. A classic question, it's a very straightforward question. We're basically saying 7 by 9 combined with 9 by 13 to give a 3 by 4. An alligations method, subtract this, plonk it here, subtract this, plonk it here, get the ratio, simplify, then you're through. And so this, you should have done tons and tons of questions on this. On simple alligation, if you have not done, pick up a book or go to the 2IM online page or go to the online course and get to drill and do 25 questions and allegations, you're through. If you've not done that, you should be doing it today. Go to sleep late, it'll pay off. Time consuming, probably something that you can keep for later. So we have 2 and 3 in the bag, 2 questions in the bag. So far, this lovely question. You need to start think the key fact here, well, 20% of the rest. Right, so this rest is important. If you get that, you're doing this. 3 questions in the bag, 3 so far. Again, very regular question. Mark this increases by 2 inches, so x becomes x plus 2. So if average of 22 average of $20 is x, of 22 is x plus 2. Right? And or you can take this as x, this will be x minus 2. The remaining 2 who went off, their average was x by 3. This total plus this total equal to this total. Simplify that, you're through. 4 in the bag, you should be nailing this. 7th one, this is very important to think of this as x, 1.1x into 1.3 into 1.5. If you're saying something increases by 10%, it becomes 1.1x. Something increases by 30%, it becomes 1.3x. You should know that. You should be able to construct one giant equation and then knock this off. Therefore, doable. Fine. So 5 in the bag, and you're going at amazing speed. You're feeling really good about yourself. You skip those 2, the first one and the third one, stinkers. Inlet, outlet, letting go. Key point here, half full. If you mark 40 hours for this one, take a break, do 25 push-ups, and tell yourself you'll never again read a question halfway through. And to beat yourself up, do whatever it takes to gear yourself up. The answer in meters, criminal, becomes half full, criminal. If you've made these mistakes, you're walking into trap after trap after trap because you have this weird thirst for speed. Speed without detail is useless. You'll go really quickly towards the wrong place, and it's pointless. And so this detail is important. 6 in the bag. There's a freebie of a question, 7 in the bag. Right? 15n plus 12n equals 16.5 into 2n minus 150. Again, population becomes 1.4. Per capita value becomes 1.27. This y should become 1.4 by 1.27. You have a calculator, it becomes even simpler. But this way of writing down, very vital. 8 so far in the bag. You've done piece 8. If you have really a bugbear topic that you didn't like allegation, you don't like speed time, then this is probably 6 or 7. This paper is set beautifully. The tougher questions come in the second half. Right? Again, A, B, 3:4, B, C, 2:1, 4:2, adds up to 9. 9 questions in the bag. You should have got this right. This is tricky. We'll probably discuss this one. It takes a little bit of time, also a long question. So you can probably hold off on this. Still 9 in the bag. Very routine, very doable. 1 by 10 plus 1 by 8 plus 1 by k equals 1 by 4. And then done. 10 in the bag so far. A, there's a liquid, there's A, B, C. I shouldn't have gone for this. I went for this, spent a lot of time. But at that point of time, I was sitting on a buffer. I knew I was way ahead of the timer by question number 13. So I went for this, but you should not have gone for this. Still only 10 in the bag. Regular hexagon. We'll discuss this. I saw a lot of questions with this. And keep in mind, if you're following this, keep a list of question numbers in mind. I'm going to shift out of screen share mode, see the question numbers you've mentioned, and then go back to those questions and solve them in detail slowly. So if you know some fundas, this is easy. Again, it's a tough question. So 15 and 16, you're probably skipping because they take too much time. 14, 15, 16, we have skipped. So we're still only at 10 questions. And you're skipping only at 10 questions because you need to anchor these two, get the funda, remember the midpoint, and then do this. Only 10 questions. And it's tricky, only 10 questions. If you like geometry, you're going to come back to these 4. This is some simple quadratic equation, but this completion of squares, but still 10. I'm going to leave this as well. I've left 6 in a row. I don't care. This I'll do in radius of a right angle triangle, a plus b minus h by 2. Right isosceles triangle, I have only one variable to deal with. I've left 5 questions in a row. I find a comfort zone. I take that. 11 out of 20. This is a freebie. Don't do this as n into n minus 1 into n plus 1 or n into n plus 1 into n plus 2. There are 2 zeros sitting here. So there's a multiple of 100. Fine. So you need to find 2 5s somewhere. So there's a 25 into 24, 26 or 25, 26, 27 or 23, 24, 25 or 50, 49, 50. Something. Do a trial and error. You're through. Should have done that. So I'm either at 11 or at 12. This is tough. This is tough. I'm going to skip this one. This I'm doing. 13. I just have to substitute and find the value. What is there in this? This is tough. I'm skipping this one because it's time consuming. I need to know sum of the roots, product of the roots, construct a quadratic in A, and then do completion of squares. Find multiple steps, and I got this wrong as well, so I'm definitely skipping this. But right now, what around 12 questions, 12 or 13. You skipped a series in geometry. You may go back and attack those again. This is again skip. Doing well, skip this. This you should do. 2 par A into 3 par B into 5 par C, log of this is log of this box plus log of this box plus log of third box by 3. This 3 goes here, becomes 3 times this. So if we multiply this, this and this, I'll get 2 par 3A into 3 par 3B into 5 par 3C. Simplify and get it right. Right now in 13 or 14 questions. Freebie. Average of n terms is the middle term. Average of 5 terms is 90. 90 is the middle term. 90, 92, 94. This number is 47, 49, 51. It's a freebie. You're getting this. So 14 or 15 questions so far. This is tough, real tough. Skip this. Again, tough. Skip this. Tough. Skip this. Doable. If you hang in there, you can get this answer. Substitute 2 values, you're good. F of A into 1 is F of A into F of 1. You have to find F of 1. You have to substitute 1 somewhere. You get it right. So we're at 14 or 15 so far. This is tough. So I'm going to leave this one. This is doable. Just substitute a formula, you're through. We know this. I'm just substituting n equal to 1 because we've got the first term. A1 equals 3 times A2, A3 all the way till infinity. A1 equals 3 times A2 by 1 minus R. A2 is A1 into R. Find R and then you're through. If you're doing. So we're at 15 or 16 questions, there or thereabouts. This is partial fractions, so tough. So in round 1, you've got 15 or 16. If you've got this, got all of these right, you're on to a good percentile. By good percentile, I mean you're upwards of 90. When a bunch of questions here involve the tougher concepts in inequalities and functions and partial fractions and combinatorics and coordinate geometry and all that. And so I'm going to discuss a few of those. I'm going to stop sharing the screen, listen to the question numbers from you. I have about 4 or 5 questions in mind. I'm going to come back to those and then solve those step by step. And so I'm going to save out of this, discard this, and then come back for this. Go step by step. I'm going to stop sharing the screen, discuss the strategy, share the screen, and solve those 6 or 7 questions in detail. Fine. In that time window, if you're able to figure out a bunch of questions that you want me to discuss and highlight them, please do so. And so I'm looking for question numbers here, where you can tell me what specific questions you want to discuss. Otherwise, I'm going to pick some of the questions to have a go. based on what I think is difficult. Right? In terms of strategy, do only the very simple ones. Have very clear rules for skipping. From this sheet, I get the feeling that it is probably useful over preparing for geometry. The moment you see right isosceles triangle, you should be thinking 1, 1, root 2. The moment you see equidistant, you should be thinking in radius. You should be thinking a plus b minus h by 2. If you're on top of all the details, then you're rushing through geometry, on good measure coordinate geometry as well, because you know rectangles bisect each other. So I've got requests for 22, 24, and 32. I'm going to do all three, definitely. The others I'm going to think about. I have a few in mind because I went through that. So 22, 24, and 32 we're doing for sure. Right? So even in this paper, even though there were a bunch of nice tough questions in geometry and coordinate geometry and a couple of combinatorics, you could have easily attempted 15 to 16. You need to think of this exam in kind of phases, in buckets. You should say, I'm going to nail my best 15, 16. If the paper is tough, I'm doing this by minute number 58. Paper is easy, I'm doing this by minute number 31. Don't set yourself a target to do everything in one bucket. Finish off and say, this is where I will end up at. Say, I'm going to hit my simple target number. If it's an easy paper, I'm doing it really quickly. If it's a tougher paper, I'm doing it that little bit slower. I'm going to take that little bit longer to do it. And so 15 to 16, if you're on fire, you're getting there by minute number 32. If the paper is tough, you're getting there by minute number 58. But don't walk into a plan where you keep on adjusting and aiming for a 32 attempts. Get 15 in the bag. Having questions in the bag is brilliant for confidence. You feel like you're on fire. You feel like you're marking answer choices and you're confident of what you've marked. So chase that. That is very vital. You put 15, 16 in the bag. Suppose it's minute number 40. Brilliant. You tell yourself, look, 20 more minutes. If I can squeeze in 7 or 8 more, I'm looking at 97th percentile. If I can squeeze in 10 more, it's 99.xx. That's where I want to go, and then go and attack a few questions. Have question numbers to go for directly. Right. So I'm going to do go back to Hangouts and do a screen share and discuss 22, 24, and 32 for sure, and perhaps a couple more as well. So let me just see which ones are worth doing once again. So I'm going to try this and go step by step. A bunch of simple ones I'm not covering again. It's an interesting question. Maybe we'll come back to that later on. Seemed to be a very funny question. So A, B, C, D, E, F. So let's do this. It's a regular hexagon. I'm going to go to the pointer mode. So we have a regular hexagon of side 1 centimeter. So I like regular hexagon. Regular hexagon is 6 equilateral triangles. I love that idea. I know all the angles. Side 1 unit, 1, 1, 1, 1, 1, 1. A, B, C. I know the regular hexagon, angle is 120. So you have an isosceles triangle with angle 120. This is 1, this is 1. I know that for an isosceles triangle of side 120, the sides are in the ratio 1:1:√3. How do I know this? I know I can draw this. This is 30 degrees. This is 60 degrees. Sine 60 is √3 by 2. This is √3 by 2. This is √3 by 2. Overall is √3. So I know AC measures √3. The area in square centimeters of a square with side AC. So AC is √3. √3 into √3, 3. And so AC measures √3 square centimeters, √3 centimeters. And 1:1:√3 is the ratio of the sides of an isosceles triangle with one angle equal to 120. So 1:1:√3. This triangle is your 1√3, 2 triangle. I know that. And therefore I know it is √3, therefore I know √3 into √3. So I'm going to go towards 22, 24, and 32. So again, it was an interesting question. Not too difficult, very doable. Surprised that people didn't ask for 17, but that's probably because we took a while solving that. 18 was also solved in great detail. 21, 22. The first step, we know that we are looking for a range. We're not looking to solve and get x. So I want to know log 5 to the base 3. We want to think about where does this lie? And what range is this number going to be? Forget about this. When log 3 to the base 3 is 1, log 9 to the base 3 is 2. So this is more than 1 and less than 2. Log 5 to the base 3. If log 3 root 2 to the base 3 is, 3 root 3 to the base 3 is 1.5. 3 power 1.5, 3 root 3. That is close to 5. That's what we are looking for. But I know it lies between 1 and 2. That much I know. I'm looking for a range. Remember that. And so I'm going to think about log of 2 plus x to the base 5. When does this become 1? Log of 2 plus x to the base 5. When does this become 2? 2 plus x should be 5. 2 plus x should be 5 square, which is 25. Or x is 3, x is 23. When x is 20, and x is 3, this becomes 1. When x is 23, this becomes 2. This is between 1 and 2, or x should lie between 3 and 23. I'm just substituting and trying to find a range for this. Saying where does it sit? That's what we want to evaluate. This one. Super. Let's see P and Q are roots of this equation. Ax square plus bx plus c equal to 0. That were an equation with roots P and Q. Then P plus Q is minus b by a. P into Q is c by a. For our equation, P plus Q is minus of a plus 3. P into Q is minus of a plus 5. We want to find the minimum value of P square plus Q square. I want to write this in terms of P plus Q and PQ. That's what I know. I want to find the minimum value of P plus Q whole square minus 2PQ. Or I want to find the minimum value of minus of a plus 3 the whole square minus 2 times minus of a plus 5. Or I want to find minimum of a plus 3 whole square plus 2 times a plus 5. I'll write this down in the next slide. We want to find minimum of a plus 3 whole square plus 2 times a plus 5. Or we want to find minimum of a square plus 6a plus 9 plus 2a plus 10. A square plus 8a plus 19. You can differentiate and all that, but I hate that. I don't want to differentiate. I want to do completion of squares. A plus k the whole square is a square plus 2ak plus k square. Then 8a sitting here. Or I can think of this 8 as 2k. 2 into 4 is 8. So if I had a square plus 8a plus 16, that would be a plus 4 the whole square. Or this number, this expression is a plus 4 the whole square plus 3. I get to 16, I want 19. The minimum this can take, the minimum value this can take is 0. It's a perfect square. It's a square. It cannot be negative. So we're looking at 3. This very helpful that I have probably looked at 100 quadratic equations and done completion of squares on them a bunch of times. And practice completion of squares probably 50 to 100 times. So I can look at any equation and therefore I can think of it in terms of an x plus a the whole square plus or minus something. Right? So get that drill in quite a few times. You'll have to look at a question, figure out what you're doing, and then jump into the method and fall into autopilot. And so here I'm thinking and solving till this point. After that, I'm just going from memory. I know how this completion of squares gig works. That's what I'm going to try. I'm going to fall into that. And so do the practice, do the drill. It's golden. Here, 9 is 3 square, 4 is 2 square. That's all we're doing. Nothing more than that. And don't be intimidated by so many numbers. Think of this as 3 square whole power x minus half. Minus 2 power 2x minus 2 equals 2 square 4 power x minus 3 power 2x minus 3. We discussed in depth. This we did. Just for 28 we did in depth. So I'm not going to discuss 28 again. 29 I thought there will be a request. 29 is based on the formula n plus r minus 1 c r minus 1. But we actually did this by trial and error. And that works. And the numbers are small, back your gut. This was a time-consuming question because there's no direct, simple method. I don't even know whether my answers were right. So it's theta as well. So be slow, be steady. Don't rush through this one, or better to skip. 32. See, mod of 2x minus 5 plus 7 minus 2x. This mod 2, which is 2. Modulus of 2x minus 5 plus modulus of 7 minus 2x should be 2. Now this is wonderful expression. Modulus of x is x if x is greater than or equal to 0, minus x if x is less than 0. This is the expression way of writing this. And so 2x minus 5, modulus of 2x minus 5 is going to be either 2x minus 5 or it's going to be 5 minus 2x. One of these two, depending on where x falls. And 7 minus 2x, either going to be 7 minus 2x or it's going to be 2x minus 7, depending on where x falls. I add 2x minus 5 and 7 minus 2x, you'll get 2. You add this and this, you get 4x minus something. That doesn't work. We wanted to add up to 2. And just now I'm realizing that I got it wrong, that the answer should have been this, should have been less than or equal to and less than or equal to. I'm going to gloss over that. I'm going to assume that that mistake didn't happen. Fine. So if you add this and this, we get a minus 2, which is impossible. The numbers are going to say that's not possible. And the only way we're going to get a 2 is if you add this and you add this. Or 2x minus 5 should be greater than or equal to 0. And 7 minus 2x should also be greater than or equal to 0. 2x is greater than or equal to 5. 7 is greater than or equal to 2x. X greater than or equal to 5 by 2. X less than or equal to 7 by 2. This right here is the answer. I completely missed this less than or equal to. But I should have paused to think. I had so much time to burn. By the time I came to question number 32, I knew I had 15 minutes left. I had only 3 more questions, including question number 28 after this one. So I should have paused and gotten it right. So speed. So in a paper which I technically finished 7, 8, 9 minutes ahead of time, I've got something wrong. Okay? So please don't make that mistake. 33 and 34 are fine. We've done this. Partial fractions, we've discussed it at depth. So if you have a doubt, just Google partial fractions 2IM. You'll find a gigantic blog article and discussion on this, or go into the course and just Google partial fractions. You'll be able to find that. Okay. So we've discussed almost all the questions. This again is a wonderful question, time consuming, but doable. Try the paper one more time. Definitely try solving the 2017 paper before you take CAT. Absolutely no two ways about it. This is a wonderful experience. It's as close to what you can get to the real CAT. This is the real deal. They're basically saying this is the actual paper which was there. And so make sure that you try this paper in some form. The DILR section, quant section, BRC section, somewhere. The PDF that is there, visible, available, is brilliant because it lets you see the question, it lets you try it, it lets you to check the answer one question at a time, just like that. But you don't need to be on a fancy UI. You can just check that answer in one click without knowing the other answers, and then click to see a YouTube solution and verify whether the method you picked was right, better, worse, and what else could have been there. Maybe you can see the chat window. You can see the chat window at that point when that question is being discussed. So use that PDF as a base material for having a go at this paper. Right, so wonderful paper. I had fun solving it the first time around, and I quite enjoyed doing it this time as well. I got a question wrong that time. I got at least one question wrong this time as well. I will see if there's something else wrong as well. Obviously, if there are some comments you have where you want to say if they've been overlooked something or made some mistake, do make that point. We would love to hear from you. Thank you, guys. I'm going to sign off. I hope it was a useful session. We will come back and do one more session before CAT for sure. General preparation, what you should do in the last week, last 2 weeks, etc., etc. From now, consolidate, practice what you know, dump what you find tricky, take lots and lots of rest. If you're well rested and all gung-ho on the day of the exam, that adds 15, 20, 25% to your score. And so make sure that you have adrenaline going for you in the last lap. So make sure that you work aggressively on that. That's what all us guys with experience will tell you. So now is the time to sit back and not really worry about one formula and one detail, but take in all the information and gear yourself up. Okay? So guys, I'm going to sign off now. Thanks a lot for hanging in and making the session happen. Thank you, and best wishes for CAT.